Okay. Good morning. I think we'll go ahead and get started. I'm Larry Wright. I am in the PMO Central Office. I work for Missy. I'm a business analyst. And it's my pleasure to introduce these gentlemen today. They're going to be speaking to you about technology at home, learning what fellow ODOTers do, and how they make technology work for them in their home place. So we have, and I don't know if you guys are speaking this order or not, but we have Mike Arps. He's a software developer at Central Office. Mike has been creating video games since a very young age. We'll talk about that. We have Ed Thomas. Works at District 12 as an Infotech 3. He also works with something called a Raspberry Pi. Raspberry Pi. That sounds good. Josh Oswald manages third-party apps and ServiceNow delivery teams in Central Office. In his spare time, Josh has automated his house for lighting, climate, entertainment systems, and appliances. And finally, Kevin Hartman is our infrastructure administrator. A small group of Central Office IT guys, Kevin, Charles, Jack, Taylor, and Josh, also use blockchain, which we heard about this morning. They use blockchain technology to mine cryptocurrency at home. So I want you to give them a round of applause.
Hello. So that's me. I'll be talking about game development because that's what I like to do at home. Because I'm crazy. So yeah, I've been playing games literally. It's one of my first memories. Playing on Commodore 64, even before the original Nintendo came out. Moving forward a little bit, at a summer camp when I was 12, I learned. They showed me the basics of how to code, and I was like, "Oh, this is really cool." And then I quickly realized, I can take this and learn how to actually make some games with it. So that's pretty good. So I played around, just did a lot of little prototypes, just messing with stuff. Funny story, I was in high school and everybody had the TI-83 drafting calculator. So I was having fun programming with that. I made a little game where they basically counted from 1 to 100, except after 75, it showed a question mark, and you had to try to time it to get as close to 100 as you can. So I thought it was pretty fun. I showed it to my friends. They thought it was cool. It spread around, I guess. And a couple of years later, someone came up to me and was like, "Hey, look at this cool game I found," and it was my game. So. Then I kind of focused on, well, the reason why I did not go into the game industry is because they worked like 100-hour weeks, and I heard all kinds of horror stories, and I'm like, I want to have a life, so I'm not going to do it. But then a couple of years ago, I decided I developed my skill set, and I think I could actually do this in my spare time, and so I kind of started getting more serious about it. How to make it. There's parts of it that are similar to other kinds of business software development. We start from small systems, break things down into their base components, and then build things up. In game development, it seems to be even more difficult and important to start small. You don't want to start making your giant dream game. You want to start making Tetris or something. Don't make anything that needs that many buttons either. So, if you're going to make a game, you're open. So, this is what we have. Blank screen. Where do we start? Any ideas?
Small.
Small.
Small. Good. Well, what's the smallest thing we can do?
One block. No.
Pixel.
Right. Let's draw something on the screen. It's a good idea. There we go. We have a dot.
We're done.
Doing good. All right. So games need to be interactive, right? So let's throw in some programming. Make it. All right. Cool. Now we got a movie now. Feeling good. What else can we add?
Sound effects.
So
Yeah, you need sound effects.
that's step 5. Maybe we'll get there later. Let's add in something for the player to actually do. So let's add in some shooting. All right, cool. So now we're shooting stuff. Except now we need actually something to shoot. So we need to add in some eggs.
Teslas.
All right. Got an enemy. We're shooting. Oh, wait. We forgot to add collision detection. Nothing happens when I shoot.
Sound effects.
Let's fix that. Okay, good. Now we're here. And we added some logic so he disappears. Cool. That's a pretty easy game. So here, let's add in a little bit of AI. So now he moves around. Okay. That's pretty cool. So that was too easy. So let's make him come back when we kill him. Okay. Cool. So now he keeps coming back when we shoot him. That was still
Oh
too
my
easy.
God.
So let's add in some more enemies, make it more interesting. You can see we're kind of just taking it step by step and building, and now we're getting to something that's kind of resembling a game. It's kind of fun. So let's add in something really cool now. Let's add in explosions.
I like that.
And you can see just adding in the explosions just makes it a lot more fun. And it's really fun to do that as a game designer, just adding those little things that, like, oh, now the game just feels so much better. It's great for just keeping you going through the process. And this is the last slide I have for this, but you can see from here, you can add in sound effects like you guys were saying, or many different ways to go from here. Whatever you want to do. You can add in another yellow dot to be another player helping you. You can add in some walls, obstacles, whatever you want. Kind of figure out what your game is going to be.
Can we play this on the computers at work? Bad question. Sorry.
I made this in HTML5, so technically, yeah. I did this at work. That's also why I'm not really showing you my games on here, because I thought that would be bad to download some actual games on the work computers. Alright, cool. So let's talk about the challenges that are unique to game development. The big one is you don't have a feature document. Like, it's just whatever you want to do. So your goal is to kind of take an idea and just make it more fun. And what does that even mean? What is fun? It's hard to define. But we have some ideas. So learning is a big part of fun. It's why people play games, to learn new things or to feel new things. And it's exciting. Each game can be like a whole new world to explore. And as you learn and play with things, you get more competent at it. So games are a safe place to try out these new things. And the neat thing about games is you get immediate feedback. Did this work? Did I make the jump across? Yes or no? If you didn't, okay, you can just try again. And this rapid iteration of success really kind of empowers you. And this is also why they're starting to try to use games in more of education, because then you can just try it and keep trying it and get it right. And it makes it feel good when you get it right. So, planning. So once you get competent at the game, you can start to kind of visualize, okay, this is what I want to do. I want to jump over this guy and shoot this guy, and then get to the next part of the level. And when you do that, then you start really getting engaged and really feeling it, getting into it. That's when you really start to have it. All right. So, how do we create? So, prototype. This is the most important thing. Just throw together, think about it. There's always way too many ideas than you can actually make. So what you need to do is just pick some that sound good, make a really simple prototype, and sometimes just you have this fuzzy thing in your mind, and actually putting it together, it's like, well, that didn't work as well as I was hoping. So let's put it aside. Maybe we can work on it later, probably not, but go on to something else. Some people have made it their mission to just go ahead and make a game, like one game per week for a whole year, just to go through this process and get good at it. So once you have a prototype you think is pretty fun, isolate what really makes it fun. What's that core mechanic? So anybody familiar with the Halo franchise? Okay. So I got a quote from Jamie Graysinger. He worked on Halo 1. And he says, in Halo 1, there was maybe 30 seconds of fun that happened over and over and over again. So if you can get 30 seconds of fun, you can pretty much stretch that out to be the entire game. Encountering a bunch of guys, melee attacking one of them before they were aware, throwing a grenade into a group of guys, and then finishing off the strikers. That was their 30 seconds of fun. And they kind of built up the rest of the game around that. Mario 64. If you guys played that, it's fun to just kind of run around and just dive. And that's because they spent months just working on that part of it. Just the fun was just running around, playing with the camera, just moving around. And once they were happy with that, then they built out the rest of the game in the levels to show off how the different ways you do it. So we have an idea. We think we're going to go with it. It's cool. All right, so how do we do this? So first, you have to make sure you have a good vision of what your game is. Figure out what you think the game is, what mechanics fit together with the theme, and how everything kind of supports each other. It's like in a movie, you can have a good scene, but if it doesn't really support the story, then it should probably be cut. Find the flow. So flow in a game is kind of when the player is their most engaged. It's not too hard, it's not too easy. The player's just having fun. Getting into it, things kind of work as they expect. They understand what's going on. And then play test a lot. Find other people who haven't played your game before, and sit them down in front of it and just watch them. You don't even have to do a survey or anything. Just watch them play, and you'll see. Oh, why are they doing that? It's not silly. They're not doing it the way I thought. And players are great at identifying problems, but they are not good at diagnosing. They'll tell you what is wrong, but they don't know your vision, so they don't necessarily know how to fix it. There was a game, I'm not sure which one, but a gun felt too weak to the players. So they were like, you should increase the damage and everything. And developers looked at it and they're like, no, actually the damage looks okay. But you don't like this gun, so we're just going to add a bigger sound effect. Bigger boom when you shoot it. So, okay. And then they released it, and it's like, yes, thank you, this is the greatest gun ever. All right. So, let's do it. Let's make a game. Which game engine It doesn't really matter, honestly. Any of these are good. Unreal is a big one. It makes your games very pretty, just kind of out of the box. It's a little bit harder to get into. It's C++. Unity is used like everywhere. Tons of tutorials out there. That's what I use. And the neat thing about Unity is you can kind of take your game and port it to wherever you want. Mobile, consoles, PC, Mac, Linux, whatever. Game Maker is pretty easy. A lot of people use it for rapid prototyping, even if they make their game officially in some other thing. Godot's kind of a rising star. It's a new one. It's got a lot of neat features for 2D games. Construct is another one that's easy to get into. But it doesn't matter. Just find one that kind of works for you. The important thing is to just kind of stick with it and learn it, so you're not struggling with the tools, you're actually making your game. And whenever you don't make your own engine, unless you want to just play around with making your own engine, because you're never going to get a game from yourself. So, you want to make a game. Let's see what happens when you actually release it. So, Steam released, Steam, if you're not familiar with it, it's the most popular PC store. So, they had about 21 games released every day last year. So, making games stand out from that is a challenge for sure. Well over 90% of the games lose money. It's hard to find an exact statistic on that, but most of them you just get 100 downloads and that's it. So the big thing is you have to know how to market. You have to. There's a lot of games now that are just built with that hook, like, and that's how they figure out which game that they're gonna make. It's like which one sounds the coolest. For example, Crypto the Never Answer. So it's a roguelike, like randomly generated dungeons where you move around, try to kill the enemies, except you're doing it to the beat of the music. So they went to convention. They actually had a dance pad out there, and people were doing it. And you got a lot of news, and a lot of people heard about it. And it's pretty cool. So, but that's people are building games like that now. Like this is going to be popular because it's different. So, should you make a game? No, you shouldn't. I would not advise anybody to do it. But if you want to do it anyway, cool. Then you might have enough determination to actually finish it. So I'll leave you with a quote from Shigeru Miyamoto. You may have heard of names like Mario and Zelda, so these are names. I enjoy thinking about ways to create something I know other people have not even thought about, something no one has managed to achieve. So that kind of, he likes just taking his own ideas, not really looking at what anybody else is doing, and kind of doing his own thing, which is cool. I think that's what a lot of people should do. So, if you're interested in game development, and none of what I said has dissuaded you, then you'll do it. So here's a screenshot of one of my games. You can find a demo out there of those games. That's all.
My name is Ed Thomas. I'm from Hvac, Special Information Technologist at District 12. I'm going to talk about this thing called Raspberry Pi. Not this one. Yeah. Sorry about that. But this is about a Raspberry Pi computer. It's actually a learning tool for kids, and it turns out to be much bigger than that, as we'll find out in a little bit here. You can use it to program your own things that you want for your house, as you'll find out shortly here. We use it I use it to control things around the house. It's a series of single-board computers developed by the UK by the Raspberry Pi Foundation. And its purpose was to promote teaching basic computer science in schools and in developing countries. The foundation's goal was to offer two versions priced at $25 and $35 plus local taxes. And even though it's progressed over the years, it's still remained at those two main price points. Since it started around 2012, it actually was sold for $35 then. It's still sold for $35 now in the board, as we'll find out here in a minute. Even Upton is the founder, or co-founder actually, that developed it. And this is a quote from him, and he said, "The lack of programmable hardware for children, the sort of hardware we used to have in the 1980s, is undermining the supply of 18-year-olds who know how to program." So that's a problem for universities, and then it's undermining the supply of 21-year-olds who know how to program, and that's causing a problem for industry. So the whole idea is to get people involved at a young age to try to learn computing and this, the tools that are used to create, new technology basically. So it was, meant as a learning tool primarily, but can be used for other things. In 2011, the Raspberry Pi was developed. It wasn't released then, but it was developed in 2011. The foundation started accepting orders for the higher price model on February 29, 2012. The higher price being Model B, as we'll find out shortly here. The original model became far more popular than anticipated. This is the beta version of the board. Actually, let me pass these around here. There's two versions. Model B, you could just pass them around to everybody. Model B, the Model B is the first one, and the Raspberry Pi 3 is the second latest one. So you just so you can kind of see what they look like. Okay. The first one came with two USB ports, an Ethernet port, an HDMI port, video out port, and a audio out port. And it also had the pins on the top there. Let's see, here. Pins right up here are general purpose input-output pins. And you can use those to program anything that you can hook to it, basically a relay, switches. You can also have input, like if you have switches you want to be able to have to tell the computer that something's happening, you can actually have a switch hooked to it if you want. But back to the different models of boards. This is the first revision. That's the first one I have passed around there. It's the Model B. That was released in April of 2012. And the Model B revision 2 came out, not much different, but it's the one on the right. Its primary purpose, I think, was a faster processor. And then the next one is, this is the Model A, which was the $25 version, which does not have an Ethernet port, and it only has one USB port. So the whole idea was they basically cut the prices down and made it a little bit more affordable for people who didn't need those things. Model B Plus, this is the somewhat of a bigger difference. You have the 40-pin header, which added, I believe, it had 26 input-output pins, and the old one, which only had 26 pins, only had 17 input outputs that you can actually program to do whatever you wanted to do. Model A, this is the Model A Plus, also does not have Ethernet or USB. Model Pi 2, Model B, sorry. There isn't much different. The difference with this one is the Broadcom chip is much faster, and it has 1 gig of RAM instead of 512. This is the Raspberry Pi Zero, has 1 gigahertz processor. It does come with Wi-Fi in this one, and Bluetooth, and it has a mini HDMI and micro SD card slot. It supports many operating systems. Android is one of them. Very many different Linux operating systems, Arch Linux, CentOS, Debian, FreeBSD. The primary one is Raspbian. It also supports Windows 10 IoT Core, which is fairly new to the game. But Raspbian was the official, operating system of the Raspberry Pi. The operating system now comes in 2 flavors. It's a light version with no desktop, and it also comes with the full version, which has a desktop. Both can be run with or without an attached monitor, so if you have something that just runs in the background and does stuff, then you don't have to hook a monitor or a keyboard onto it. This is the original desktop of the first Raspberry Pi. It's pretty plain. I mean, it had basically a start button down here, just like the Microsoft Windows and start menu. But it was very basic. Then they advanced all the way up to the current day, which is this one. This is the new Pixel desktop. Start menus up on the top upper left-hand corner, and it's more of a Linux environment. Raspberry Pi 3 Model B Plus. This is the newest version. It has a 1.4 gigahertz core processor, 4-core processor, gigabit Ethernet, which maxes out at 300 megabits per second, and also has Wi-Fi. There's no way to officially tell, but there are probably thousands of Raspberry Pi hardware add-ons available today, one of which is the Raspberry Pi camera. You can actually has a camera interface on the board. On the board you'll see there's a special connector for ribbon connector specifically for the camera. There's also, this is the Pi Face I/O board. It has 2 relays and it has 8 input outputs. It has a Pi Face control display. It has a little LCD display you can use to program stuff. And here's something that I use at home. It is an IQ Audio Pi DAC. It actually has audiophile quality audio. You can actually hook it up to your stereo system and you can control it from your Wi-Fi. The Raspberry Pi is a full-fledged computer. It can also run a small but growing number of 3D games. One of them being Minecraft, Doom, Quake 3. Now this, if you notice here, this is kind of interesting. 1 frame per second, if anybody knows what that means. Very, very slow. But it can do it. So, the Internet of Things is a network of physical devices, vehicles, home appliances, other items embedded with electronics, software, sensors, actuators, connectivity which enables these things to connect and exchange data, creating opportunities for more direct integration of physical world into the computer-based systems, resulting in efficiency, improvements, economic benefits, and reduced human exertion. Basically, it allows you to do things, a little bit more automated and stuff like that, like Alexa and stuff like that. As everybody knows, that's all based on this kind of technology. Humans are now so busy and looking for anything that can save a few minutes of time. Many devices are now available and more are arriving each month. Here's a quick comparison. The Jetsons, they had basically a smart refrigerator, if you will. They chose what they wanted. Nowadays they have a refrigerator. They had robotic vacuums, dog walkers. Raspberry Pi and numerous other platforms that came about primarily due to the Raspberry Pi have spawned a maker movement. The maker community already has and continues to add inventors, thinkers, etc. every day. Following video, this is the last thing. The following video will demonstrate some of the basic possibilities of using a Raspberry Pi on the microcontrollers to control the garage door and receive updates every time the door opens. This was developed over several months with some trial and a lot of errors. That's the key thing here. If you're going to do this, you have to be prepared to make errors. So here we go. Let's see if this works here. Let's start this here. While I was clicking on the open door, this can be done from my cell phone or my home computer. Opens the door. This is all from a Raspberry Pi and what we saw earlier, the Pi Face relay board. It just has, all it does is the relay just closes for half a second, and it basically hooks to the same 2 wires that the garage door button connects to. Pretty simple. And also, there's 2 inputs that actually tell me when the door's open or closed. Now, we're not going to do this now due to the lack of time, but I was going to show you live demo, basically what we just saw. To summarize, the Raspberry Pi is a huge success for education communities, selling tens of millions. It supports many operating systems. It has a wide variety of add-ons. It can be used for IoT applications and has made its way into the maker community. While it may seem daunting at first, learning this new technology can be fun, and don't be afraid to make mistakes. And that's basically it.
How much does that board cost?
$25.
$25. Does it
There's a
need
$25
cool?
version that's the light version, if you will.
Does it need cool?
Does it need what?
Cooled.
Code?
Yeah, it has heat sinks.
Heat sinks, okay.
Cooling.
Cooling.
Cooling. No, you can actually add heat sinks to it if you want to.
Okay.
On Amazon, it's like
There's cases available.
$49 for the whole kit and everything all together. It's not bad.
They have them in Micro Center.
Yeah.
All right, good morning. I'm Josh Oswald from Central Office IT, and I'm going to talk about one of my many hobbies, which is home automation. First off, I want to kind of explain the goals I have, which I think are pretty common. The first one is convenience. This kind of appealed to me for 2 reasons. One is I kind of like machines to do my bidding. I shouldn't have to go turn on a light when I enter the room, turn off when I leave. I can get a machine to notice I'm there and do it for me. I shouldn't have to track how much water my lawn gets and do it when I can get a machine to do that. Secondly, it kind of appeals to my natural laziness. Every time I want to watch a movie, turn on the TV, turn on the DVD player, turn on the stereo, I can just say, computer, play a movie, and it will do all that for me. It'll turn down the lights, it'll turn off my doorbell. I have not yet automated a popcorn maker, but that should be next. Another goal is safety and security. I don't know, I'm sure someone has been in bed at night and thought, can't remember if I closed the garage door or not. If I left any windows or windows open, doors unlocked. Maybe some people have a swimming pool and they'd like to be notified if the gate to their pool opens. This aspect went a long way in selling my wife on the idea of home automation, because she's usually the one laying in bed wondering if the garage door was open. Energy savings is another key piece. I already mentioned being able to shut lights on and off automatically. There are devices that will let you monitor power usage, both for your whole house or for certain devices. You can also automate using smart plugs to turn off devices that still use power while they're turned off. And the final goal was just to do some cool stuff. We get to do some cool stuff every day at work, but this is a little different. Figuring out challenges and solving problems at work are different than kind of the example I'm going to show you next. And I'll warn you, I don't know how loud this is going to be, so bear with me. Not loud at all. So what it said was, Alexa, play a Christmas song.
Is this your house?
So unfortunately, that is not my house. I don't have that kind of free time either. But this is a very complex automation, but this is an example of what you ultimately could do. So my approach to implementing automation kind of was three-tiered. First of all, it was incremental. When I was researching this stuff, I found a lot of people that would go out and buy everything. All these sensors, devices, and number one, that's super expensive. And number two, it takes a lot of time to implement all that. So my goal was not to automate all of the things at once. My goal was to be solution-driven. I would find a problem and then think about how to solve that problem. I'd figure out the logic, I'd buy the pieces I need, and I'd implement it, and most importantly, test and change until it worked. And lastly, it had to be simple. If somebody has to change their routine, if they have to do something different, if they have to learn something new, then it's not a very good automation. I don't want to add complexity. And this is commonly referred to as the spousal acceptance factor, because if the spouse doesn't like what you're doing, it's not going to last very long. So even with the complex automations, the basic components are the same. We start with inputs, and Charles talked about this a lot. We want to get information into our system, and this is done with sensors. And there are a ton of different kinds of sensors. There's light, there's motion, there's open, close, even things like power, power, smoke, water for security type sensors. Next is the control, and this is kind of the brains of the system. This is where we tell the computer, the system, what we want to do. And this is commonly referred to as the hub. It takes all of the inputs from the sensors, it applies the logic that we give to it. Something like, hey, I saw motion in this room, turn on this light. And it then sends information to the doers. Those receive commands and they perform actions. And the doers can be anything from a simple light switch or a bulb to remote controllers, inputs to other automations, or as you'll see, Raspberry Pi devices. So I'm going to give some examples of problems I've solved. This is my dog, and this is his hungry face. And the problem that we would have is he's very good at repeating this every night. So I may go feed him, and then one of the kids may go feed him, and then my wife may go feed him. And he'll sit there and pretend to be hungry. So the way I solved this was to put a sensor on his food container. And when we open that food container, a couple of things can happen. If we open it for a short time, we'll get an announcement that should sound like this.
Duncan was last fed at 6:04 p.m.
So we know that he's already been fed for the night. If we keep it open for a few more seconds, the system determines that, hey, he's already been fed, it records the time and updates it. So that sensor sends information to the hub. The hub does the logic and sends that message to a Raspberry Pi device, which plays it over a speaker. The next one is wasting HVAC. So I have small sensors on all the doors and windows that can tell if the door or window is open. What happens is when my smart thermostat starts up, it sends a signal to the hub, and the hub checks, hey, is anything open? If it is, we'll get a notification.
Air conditioner is on and the following windows are open. Master bedroom south, kitchen.
So we know, we don't have to guess, we know exactly what windows or doors are open. We can go take care of it. And we also get a notification on our phones too, in case we're not near the speaker or we're even away from home. That also uses the Raspberry Pi and a Bluetooth speaker. This one, so a lot of washers and dryers now have alerts to tell you, they'll send you a text or send a message when your laundry's done. Mine don't have that, so I solved it with a little bit of home automation. The technology I used here is a little different. I used a smart plug, which is typically just used to remotely turn devices on or off. But some of them have the ability to monitor how much power is being drawn. And that's what I did. The hub monitors the power being used by the washer. When it detects it goes into a low power state for a certain number of seconds, it says, hey, the laundry must be done. And it'll play a message and send me a text.
The washing machine has finished.
And finally, one of my most complex automations, and this one kind of solves two problems. One is the unauthorized drinking of my beer, and two is the surprise of an empty keg. So the main piece that runs this is a custom software application, and you're seeing the UI here. I did not write it. It's actually freeware, but it lets me put in all the information about what's in the kegerator. it takes information from the sensors and it sends out actions. So there are some very different sensors in this system. There are 2 flow sensors, one for each keg, and those flow sensors just put out pulses as the beer flows through the keg line. There's also a temperature sensor to monitor the temperature inside the kegerator, and it just puts out a voltage. So we need to turn that information into some useful data that the system can use. So in addition to a Raspberry Pi, which this system runs on, we use another small mini computer called an Arduino. That Arduino connects directly to the sensors, turns it into useful data, and sends it to the Raspberry Pi. Additionally, I see all of this on a mobile tablet that I have mounted on the wall above the kegerator. So I get an alert if someone pours a beer. I get an alert if the keg is running low. And I can also configure the tablet to take a picture of whoever's pouring the beer so I can catch the culprit.
It appears you need some help drinking through that beer.
How many times has the dog been busted?
You got your priorities.
Fortunately, he's too short for that. So this is a quick recipe for getting started. These are 3 basic components that would be a start to a home automation system that can be built upon. The hub, I put up here a SmartThings hub. There are lots of different hubs. This one's relatively inexpensive, $50. It works really well. It communicates on the 2 primary communication protocols, and it just generally works. So this is one I recommend to people. A motion sensor. There's a million of these things. You can get them from $5 up to $80. I like this one. It's right in the middle range, $30. It's actually tiny. It's about this big, so you barely see it in a room, and it works really well. It's really, really reliable. And then this is a smart bulb. There's a ton of different smart bulbs out there too. The thing I like about this one, some of them connect to Wi-Fi. Most people have a Wi-Fi network in their house. Some of them connect directly to the hub. This one connects directly to the hub. So putting all this together, you would have the motion sensor detect you walk into a room and send that information to the hub, and the hub will tell the bulb to turn on. And then you can tell the hub, hey, after 5 minutes of not seeing me in that room, turn the light off. So that's a very basic automation, and obviously since you have the hub, you can now add all the other sensors and all the other doers or bulbs to it. That's it.
Good morning. I am going to talk about blockchain. This is something that I mess around with at home. Jack Taylor, who many of you may know, Josh Oswald, Charles Ash. We all do this at home. Primarily, we're doing cryptocurrency mining, but that involves blockchain technology. So I'm probably going to talk a lot more about what the blockchain is than actual blockchain mining. Although I will talk about that as well, because I think that generally people have heard the word blockchain, and if you were using your phones for Charles's presentation downstairs, you can use them for this as well. You don't have to though. What's that? It's not activating? How do I activate it?
Too late.
Too late? No, it's not. It's never too late. It didn't activate? It's baloney. Show of hands. How many people in the room have ever heard of blockchain? Right. Just about everyone. How many people, show of hands, in the room actually know what blockchain is? Many fewer people. This is pretty common, and there are a lot of misperceptions about what blockchain is, and I think that it's just not clearly defined, right? What exactly blockchain means. So the answer is blockchain has many meanings. Just like a phone has many meanings. If someone's talking about a phone,
They might be talking about the idea of the telephone network as a whole. Phones aren't working. They might be talking about a specific phone, like the new iPhone that they just got, or the rotary phone that they've got at home, which there are probably 10, 12, 15-year-olds who've never even seen one, which is terrifying to me. Or maybe they're talking about a specific use of the phone, talking about talking on the phone, or they're talking about playing a game on their phone, or they could be talking about a lot of different things that have to do with the phone. Similar situation for blockchain. What is blockchain? Well, it might just be the idea of the blockchain. Oh, it is a technology that exists now, that did not exist before. Okay, that's a pretty generic description. Someone might be talking about the specific blockchain that underlies Bitcoin, the specific cryptocurrency, Bitcoin or Ethereum. There are a zillion cryptocurrencies out there, and each one of those technologies has its own blockchain. And each one of those unique blockchains, have some unique properties, and they're not all connected to each other. So the blockchain that Bitcoin sits on is not necessarily going to communicate with the blockchain that another cryptocurrency sat on, or another technology sat on top of. So someone could be talking about specifically just Bitcoin, the cryptocurrency itself, not the underlying blockchain, but they might just be talking about Bitcoin. So blockchain has a lot of meanings out there. I'm going to try and help define exactly what I'm talking about when I talk about blockchain, and that is that a blockchain is really just a file, okay, and in a data structure. That is to say, how data is logically put together and stored. A couple other examples of other data structures are databases, text files, CSV files, images, lists, list goes on and on. Out of all of those examples, blockchain could probably be most closely related to, or I would probably relate blockchain most closely to, a database. So I'll explain why. The blocks in a chain, blocks in a chain, are very similar to the pages in a book. A book is a chain of pages, right? They're not necessarily all laid out one right after the other in front of you, but they're sort of, okay? You turn the pages, that is the chain of pages. As you're moving through the pages, you're moving through the chain of pages. And each page in that book contains a couple things. The text of the book, right? The data within the book. And information about itself. At the top of the page, there's going to be a title, sometimes. Maybe a chapter number. At the bottom of the page, there's probably going to be a page number. Maybe some other, footer notes or whatever. We're going to call that metadata. And blocks in the chain also have a couple things similar to a page in a book. They have the contents. So this is the data, just like the text of the book. On Bitcoin's blockchain, for example, the contents would include Bitcoin transactions and the miner incentive reward. I'll explain what those things are. Bitcoin transactions are exactly that. Who sent what to who? So it's recording transactions on these blocks between different Bitcoin wallet addresses. And a wallet address is kind of like a bank account. I'm not going to go into it. But think of it as somewhere where you store all of that cryptocurrency. So it's recording transactions. It's recording the miner incentive reward. And we're going to talk about what that is. Those are the contents. It's also going to contain some metadata. I'm going to call it a header. I'm going to walk in front of the screen so you can read it. And that's going to contain data about the block. In Bitcoin, the header includes some technical information about that block, reference to the previous block, and a unique fingerprint, or it's usually referred to as a hash, that is of the data that is contained in that block. So that data is uniquely marked by a fingerprint that no other block on that blockchain is ever going to use. So that data can be uniquely referenced by that fingerprint. With books, predictable page numbers make it easy to know the order of the pages. If you ripped all the pages out, threw them up in the air, and then picked them all up, you would be able to look at the pages, put the book back together, right? So that you could read it in the normal way you'd read a book. I don't know where I was going with that. Block by block. With blockchains, each block references the previous block, not necessarily by block number, but rather by the previous block's unique fingerprint that I was just talking about. So that, in a very similar way, that is how a blockchain can be read by the technology that's sitting on top of it, in a very similar fashion to the way. What are the benefits of blockchain technology? What is it good at doing? Greater transparency. A blockchain is not centralized. Okay, there's not some server out there that's running the Bitcoin blockchain, and if that server crashes, it's all over. Or someone is controlling that server and can manipulate the blockchain that's sitting on it. That's not how it works. Every cryptocurrency mining node, you can see one sitting right over here, is a participant in the blockchain's network. And the blockchain is running on all of those nodes in a distributed way. So I can turn that node off. The blockchain isn't going to stop working, unless it's the only node that's running that blockchain, which would be a really dumb way to do things, considering the way the technology works. So, greater transparency. All network participants share the same system of record. All of the people who are participating in that technology that's sitting on that blockchain have the same data. The shared system of record can only be updated or modified through consensus, meaning one person can't say, I'm going to change the data, and then it's just changed. If someone changes the data, all the other nodes that are running on that network have to confirm that that data was changed. It's confirmed for everybody, and now everyone can see that that data was changed. So no one can do anything sort of, behind the curtain and change data without everybody who's participating knowing about it. Therefore, the data is more accurate, consistent, transparent than when it's changed through a paper-heavy process or a manual process where someone's emailing someone else, or someone can access the system while no one else is around and change things. That's not how it works. We can't do it. Enhanced security. This is sort of related to the consensus that's necessary in order to change things. Transactions must be agreed to before they're recorded, and then once they're approved, they're encrypted and linked to the previous transaction, and they become part of the blockchain itself. So all of those transactions are recorded and visible on the blockchain at all points in time, once it's done, once it's been recorded. Increased efficiency. Manual processes can be streamlined and automated using the blockchain. And since record keeping is performed using a single shared ledger, you don't need to spend time reconciling multiple systems of record. I don't know how many times any of you have spent time reconciling documents or reconciling data between two disparate systems, or two similar documents that, one person had this document and they did some things to it, then another person had the same document, they did some things to it. Now someone says, I want one document with all that information. Now you've got to spend the rest of your day looking at all the documents and reconciling them, making them one. That's not how it works with blockchain. Once the change is made, it's made for everyone. You're not going to have multiple copies of this thing, of this data floating around. So that will increase efficiency. Decentralization has its obvious benefits. If a piece of the network goes down, if some hardware goes down, not a big deal. There's a zillion nodes running this in a decentralized way. It's not a case where if the data center loses power, the blockchain is no longer accessible. It's not how it works. That's what decentralization means. And immutability. Once data has been written to the blockchain, it cannot be changed without record.
that has obvious benefits to government, right? Once we have done something, we want the public, if we've bid something out to a series of contractors, and we went through the whole process to award it to the contractor who deserves to get that contract, they have the lowest bid or what have you, whatever the requirements are, we're going to be audited on that. Someone's going to come in and say, hey, did you bid this out correctly? Yes. Well, prove it, is what the second question the auditors will always ask. And how are you going to prove it? If you don't have immutable documentation that cannot be altered. Someone could fiddle with paper documents. Someone could change, someone could alter digital documents. I'm not saying that anyone in ODOT does that. It wouldn't make a lot of sense to do that, but that does happen in government sometimes, and that's an obvious benefit to us. If you want to be able to prove that you've done something or that some data exists, you want it to be immutable, you want it to be unquestioned as to whether or not that data is legitimate. And that's another benefit that blockchain technology provides. These are some cases for how we might use blockchain at ODOT. Internet of Things. With road sensors, we're putting more sensors on the road every day. We've got thousands, and there are many, many more that are going to come. Charles was just talking this morning about how all of these cars have sensors on them, and they're talking to the roads, and the roads are going to be talking back to them. Whose sensors do you think are going to be used in order to talk back to the cars when people are driving on the freeways? Probably ours. Probably ours. We've got a zillion different kinds of devices out there: weather sensors, Trimble GPS devices, traffic signaling devices, variable speed limit devices, direct message signs. The list goes on and on and on. And the blockchain is uniquely positioned to identify those devices using very unique fingerprints, as we were talking about earlier, for each one of those devices, so that you can identify uniquely each sensor that exists on the roads using a unique identifier that can't be reused, it can't be altered without record. You know where this stuff is, and that is one of the ways that blockchain can be applied to the Internet of Things, is that it does very well at identifying all of these unique devices and making it so that you can't, without record, change stuff on those devices. So we would obviously want to know if someone changed the message on the DMS sign. That kind of change could be very visible on the blockchain. Who changed it? When did they change it? What did they change it to? That data would be on the blockchain. Once the consensus confirms that it should be written, you have that record forever. Who put the funny zombie message on the DMS sign? We know it was Josh. We know it was Josh. Asset tracking and registration. This is something else that blockchain technology excels at. In the same way that you can use blockchain technology to uniquely identify all the sensors that I was just talking about, you can expand that concept and use blockchain technology to track assets, period. Whether it's a sensor or, a little clicker thing, anything with an asset tag, a laptop, you name it. And that relationship, once it's created on the blockchain, exists through the life cycle of that asset. Snowplows, you name it. And that identifier will live with that asset until the day it is retired. And everything that was ever done to that asset is going to be recorded as well on an immutable ledger that's distributed, highly available. You can see the benefit, I hope. Document and image digital you can read the words. We do a lot of this at ODOT, and as the manager for the security, not the security team, well, I guess kind of now that I'm the administrator, but as a manager for the storage and server team, I have watched the amount of capacity, storage capacity that we're using for documents and specifically imagery explode over the last 5 years. It is insane the number of images that this agency saves to network storage is insane. And with the stuff that Drew Williams' group is doing, I mean, they're driving around a van that's taking high definition, not just visual images, but radar images, LiDAR images, I'm pretty sure infrared images of every inch of freeway in the state of Ohio, right?
And it'll be out there. You can see it at noon. Thanks for the plug.
No problem. But the amount of capacity that that's using is crazy. And then they're taking those images and they're running very complex software against that stuff and actually making decisions based on it. What pieces of road, they're creating numbers that say what pieces of road, based on those images, are the most messed up. What do we need to spend our money on? What sections of road do we need to spend our money on? So immutable and uniquely identified documentation and imagery might become an important thing to have. A well-defined record or identifier for a section of roadway is something that could be very useful for Drew's group to have, so that when someone was referencing that section of roadway, they would have a unique identifier. You look up that unique identifier, you see everything that ever happened to that piece of roadway. And that could all be done on the blockchain, and once again, can't be changed without consensus among all the shareholders in that system. Lastly, fraud prevention and compliance. I touched on this very briefly when I was talking about previously when I was talking about how auditors are always going to ask you to prove what you're telling them and prove you've been compliant. When you're talking about blockchain, it's starting to sound like a broken record. You're talking about an append-only record of all changes to data. You're not deleting anything ever. You can say that data is no longer valid, and that'll be recorded, but that doesn't make the data go away. It's still there, and you can still see it. You can see where that might be useful in preventing fraud and ensuring compliance from an auditing perspective, that people can't hide things. People can't hide things anymore. Once it exists, you can change it. You can say that's not valid anymore, and you can give a reason why, et cetera, and the auditors would be interested in that. But you can't just make data go away without a record anymore. Huge benefit to government agencies. Challenges: scalability. This is a problem for blockchain technology. Maintaining low latency during periods of high transaction volume is a problem. When there are a lot of things going on, it gets very slow, and updates happen very, very slowly. This is a problem that's being addressed by many, many different blockchains right now. They're trying to overcome this issue, but it is a problem. Interoperability. There's more than one kind of blockchain. There are lots of blockchains out there. The blockchain that Bitcoin uses isn't natively going to interact with the blockchain that some other cryptocurrency uses. That's not necessarily a problem when you're talking about cryptocurrency, but it might be a problem when you're talking about two different systems that are built on two different blockchains, and you need those systems to be able to talk to each other in a meaningful way. Interoperability is not native. It's something you would have to design and develop in a custom way, and it's not necessarily going to be easy. There are some solutions also under development for that, such as the risk of bleeding edge technology. It hasn't been around for that long. It's not that mature, and people haven't figured out how to solve that problem. And that leads into the bleeding edge technology challenge, which is just about any solution that's built on blockchain technology is brand new. I mean, within even Bitcoin in the grand scheme of things, which is one of the oldest blockchains that are still in use, is probably only, 10 years old, ish. And most blockchains that are out there are much, much, much newer than that. And the technology that's built upon them is even newer than that. So we all know, being in technology, that the newest stuff while usually it's pretty cool, there's usually some bugs too. It's not going to work exactly like you want it to. It's not going to be as feature-rich as a mature technology that's been around for 15 years and has had a zillion iterations of users coming back and saying, hey, could you add this feature? That'd be neat. Hey, could you add that feature? That'd be neat. So that's another challenge that blockchain will need to overcome. Now, cryptocurrency mining. This is a specific use of a blockchain. What is it? Put as simply as possible, it is the process of validating and adding past transaction records to a blockchain ledger. So, what is a miner doing? Well, we were talking about how all a blockchain really is. All a blockchain really is a series of transactions, right, on a ledger. And that there are miners who participate on that blockchain in order to make sure that those transactions are recorded. That's what mining is. So each node that's participating in that blockchain network to ensure that it's running is mining. They call that mining. Really what they're doing is they're updating transaction records. Why would you do this? Mining nodes are rewarded with cryptocurrency from the blockchain protocol itself. So each blockchain protocol has its own cryptocurrency, or not all of them necessarily do, but if the ones out there that support cryptocurrency do, for creating blocks of validated transactions and adding them to the blockchain. The cryptocurrency hopefully has real monetary value and can be sold for actual dollars, or in some cases like Bitcoin, Ethereum, Monero, there's a few others, can be used to directly procure goods and services. You can buy stuff with Bitcoin. You can buy a house with Bitcoin. Someone will take a fake digital money from you and give you a house. That's been happening for years. So this reward of the cryptocurrency incentivizes participation in a decentralized network. So how do you get people to participate in these decentralized networks? You give them money. You reward them with valuable stuff. And without those nodes participating, the blockchain wouldn't work. You can't have a decentralized network without stuff that's decentralized running it. Is cryptocurrency mining illegal? Not in the United States. There are some countries that have some pretty strict policies that they're coming up with regarding cryptocurrency mining. China is not very happy with cryptocurrency mining right now because it uses so much power. And a lot of the cryptocurrency mining that's happening is happening in China. It's eating a ton of electricity in China. They're not too happy about it, and they've started to sort of curtail what you're allowed to do with cryptocurrency mining in China. But in the United States, totally legal. Is it actually profitable? We have heard that it is. We have not yet, that I know of, none of us have made a particularly large or even small sum of money from doing it, but it's been really neat. We hope someday that it does become more profitable than it is at the moment. And if you're wondering what a cryptocurrency node looks like, you're looking at one. We call this the Octo Miner. The reason we call it the Octo Miner is that there are 8 high-end graphics cards running. The reason they're graphics cards is because that's the kind of hardware that is most effective at processing the types of algorithms that you need in order to update the transaction ledger on the blockchain. Basically, these video cards process transactions. A share of transactions, or a share of blocks, is granted to these cards. They process. If they actually solve a block, then a reward is granted, usually in the form of cryptocurrency, and you move to the next set of transactions that you need to process. That's kind of an oversimplification of how it works, but I don't think we have time to really go into a deep dive. This is in my garage right now, much to my wife's displeasure. These are 12 graphics cards, 13 graphics cards, 13 graphics cards. These are 3 different mining rigs, and they're all mining a cryptocurrency called Ethereum. They get very, very hot. My garage is usually 95 degrees if it's in the 70s outside. That's why it's not inside my house. I did have one in my basement for a while, and my basement was a tropical environment.
Heat your house in the winter.
But these nodes are all participating in the Ethereum cryptocurrency decentralized blockchain network. So when they're turned on, they are supposedly making me money.
But not enough to cover the electric bill.
At the moment, I think just enough to cover the electric bill, which is ample. That's blockchain. Does anyone have questions about any of the sessions that we did? Or any of the topics that we covered?
Which graphics cards are you using?
In that specific rig, I think it's Sapphire 580. They're ATI cards. Or, I'm sorry, not ATI, AMD.
They're Sapphire Nitro.
Sapphire Nitro 5 something. See, 580. It's pretty high end.
Most of them are 580.
Pretty beefy. Yeah, one of those cards would run a pretty sweet gaming rig if you're into computer gaming.
Can we get a copy of the whole PowerPoint?
I don't see why not.
Okay.
If you do get the mining rig for ODA, are you just gonna put it in like a whole new room on the 4th floor, or just throw it into the server room and hope for the best?
You're talking about blockchain mining?
Yeah, if you get a rig, are you gonna put it in actual ODA Central, or?
We don't know. We're not even far enough along yet to have even had a conversation about where we can put that stuff.
It's just gonna be OIT managed, right?
You're fired. It's not currently a service at OIT office, so no, it would be something that we were running for ourselves.
But you know the minute you go to procure it, they're gonna say, wait a minute, we're gonna do this for everyone.
Right. Possible.
They're having this, so you know they're already talking about blockchain. It actually is a pretty hot topic with the governor and a group in Cleveland who seems to have some political clout. They're having a conference in December on the blockchain in Cleveland, Ohio. This group wants to become the blockchain center of the world in Cleveland. They want Cleveland to be the blockchain center of the world, which means they don't really understand blockchain because it's supposed to be distributed. But they are asking the state agencies, they've asked Director Ray to speak at this conference based on what we're telling the director as blockchain, and we told them we're not ready. There's nothing we can commit to on blockchain at this time. It's too new for us. We don't have anything architected. We can give you use cases for the future, but we're not there. I don't think he's going to speak. I don't think we're going to commit. But the governor is pushing.
Any other questions?
Go have lunch. I think the food trucks are here.